Alright, so we're going to try a new questions today. Now, it looks very similar to the one that we tried yesterday, but if you notice, there is a slight difference in the second vector, which is F2. So the figure shows three forces, F1, F2, and F3, acted on a particle's O at the origin. Calculate the magnitude and the directions of the resultant force on a particle O. So you look at F1. F1 is fine. Why? Because the vector is coming out from origin. F3 is also fine because it's coming out from origin. But if you look at F2, now the arrow is pointing towards origin. In this case, we have to extrapolate it. Okay, we have to extrapolate the vector and let it comes out from the other side. Okay, let it come out from the other side. And this would be the new vector that we are going to use. So in which it means if you have any vector that is pointing towards the origin or towards the object, then you have to let it come out from the other side. So the original vector, we are going to remove it now. So this one, we don't want to include it in our calculation. Okay, so we have F2 here. And then this one, F2 is equals to 30 Newton. And here would be 45 degree. How do I know it's 45 degree? Because it follows mathematics rule. So mathematics rule, if you have a two line like this, they are crossing to each other, then the angles here would be equals to the angle on the opposite side. Okay, so this would be our new vector. Okay, this will be our new diagram. So we're going to draw it here. Step 1, draw a Cartesian coordinate. Why? Because you are going to draw F2 at its new position. Okay, as a new position. So this is your F1, which is 20 degree. And then the force is 10 Newton. Okay, and then we have F2 in the fourth quadrant, which is equals to 30 Newton. And then this is 45 degree. F3 in third quadrant, okay, which is equals to 40 Newton. And this is a 30 degree. So this will be our new diagram, okay, new force diagram, which F2 is now located in the fourth quadrant rather than the second quadrant. And the next one, it's asks you to resolve the vector. So what I like to do, okay, I will straight away resolve it in the table. So F1, if you look at the diagram, it is in the first quadrant. And the angle is located beside x component, which means x component, we are going to use cos. Okay, so F1 equals to, the x component is equals to 10 Newton and then cos 20 degree. Okay, 10 cos 20 degree. I use cos because the angle is located beside x component. So if x component uses cos, then y component will be sine. So 10 sine 20 degree. Okay, 10 sine 20 degree. For F2, okay, now F2 is 30 Newton, and then the angle is 45 degree beside x component. Therefore, for the x component, we have 30 Newton cos 45 degree. Whereas for y component, again, we just repeat the value, but then we change cos into sine. So sine 45 degree. But now, if you look at the diagram, my F2 is located in the fourth quadrant. Fourth quadrant, we have positive x, but then the y should be a negative value. So you add a negative in the table. Okay, you add a negative in the table. And then for F3, which is located in the third quadrant, so again, my angle is beside x component. Therefore, for F3, the x component would be 40 cos 30 degree. And then y component would be 40 sine 30 degree. And again, if you look at the diagram, third quadrant, we should have a negative x and also negative y. Therefore, in our table, we need to add a negative sign and a negative sign in the y component. Okay, a negative sign in x and negative sign in y component for F3. So once you have all this value, okay, in your table, what are you going to do? You just use calculator to calculate the final resultant. Okay, so your Fx, okay, the resultant along the x component is equals to negative 4.0 Newton. And then Fy is negative 37.8 Newton. Okay, so this is a complete table. This table will give you full marks in your final exam, right? This table is a full marks table. So now that you have this table, what are you going to do next? So you draw the positions of the resultant force, okay, resultant vector, so that you know where is the final vector, where is our resultant vector. So let's begin from an xy plane. Always use the xy plane to make it easier. So you look at the diagram, you look at the table, sorry. Okay, you look at the table. Fx is a negative value. Fy is also a negative value. What does it mean? It means our resultant vector is located in third quadrant because you have a negative Fx, okay, your negative Fx, and then you have a negative Fy. Therefore, the resultant is in the third quadrant. This would be our F resultant. And then remember, the angle is always beside the x component. So the angle is here. Okay, so this is a diagram for our resultant vector. Fx negative, Fy negative. So once you know the diagram, once you have the diagram and you have the table, you can then proceed to calculate the resultant magnitude. Okay, resultant magnitude of the vector. So F resultant, okay, always remember this formula. It is equals to square root x component square plus y component square. Right? So what are we going to have is square root negative 4 square plus negative 37.8 square, which is then equals to positive 38 Newton, because we are looking at magnitude. So magnitude is always positive, okay, when it comes to vector. So 38.0 Newton. Remember to include the unit in your final answer. All right, because without unit, the answer is considered as wrong. And then the directions. Directions, we always use a tangent, theta. So directions we have theta equals to tangent negative 1 modulus Fy over Fx. Okay, which is equals to tangent negative 1 and then negative 37.8 over negative 4. So the modulus here. Okay, we have modulus here. Therefore, you're going to get a positive value, which is 84.0 degree. Okay. Now you have to describe this position, this location. So if you look at the diagram in the step number 3, it's located in fourth quadrant, right? In the third quadrant, sorry, third quadrant. So third quadrant, if you look at the diagram, it is below x-axis. So we start from below, okay, open bracket, below. Now, below positive side or negative side? Of course, it is negative, okay, because it's third quadrant. So below, negative x-axis. Okay, below negative x-axis. So that is how we solve it. Yes, what is the questions? Fatin? Okay. Right, so that is the final answer. Okay, you start from a diagram. So make sure you look at the directions of the vector. This is a mistake where students always make in the exam, okay, because they forgot to check the arrow, okay, or maybe they didn't see the directions of the arrow. They just look at the line. Okay, now I got 3 lines, 3 of them, they are located in different quadrants, then I can straight away answer the questions. No, you have to look at the arrow. All right, if you have an arrow pointing towards the origin, then make sure you let it come out from the other side. So this is a complete answer for the first for the 5th questions 5. All right, so I give you some time to write it down.
Madam,
Yep.
for the last answer,
Yes.
use 1 decimal place.
For angle, we use 1 decimal place. If you use 2, also fine. Okay, it's correct. Don't worry about it.
Okay.
Okay, so usually exam, we will either see whether your answer is in 3 significant figures or 2 to 3 decimal point. Okay, decimal places. So as long as your answer follow these 2 rules, then that is okay. Just don't give too many decimal places. If 1, then that is okay, because if you look at the last one, it fulfills the rules of 3 significant figures. Okay, so either 3 significant figures or 2 to 3 decimal places. So most of the times, to make it easier for students, we accept up to 2 to 3 decimal places. We check decimal places rather than significant figures in the final exam. All right, so same rules. I give you 2 minutes to write down the answer. If you have any questions, you may ask. Okay, so if you are done, then you may try questions number 6. Okay, you may try questions number 6. So questions number 6 is very simple. You have a diagram that shows a path traveled by the fighting jet. Okay, so the path consists of a 3 vector. You just put 3 vector into your xy plane. Okay, you move them one by one, you place them in the xy plane. Okay, so if you are done with questions 5, you may try question 6. Okay, another 1 minute. All right. So let's look at question 6. So question 6, now you have 3 vector. Okay, you have 3 vectors. So what are you going to do? You just place them in a same xy plane. So fighter jet starting from airbase A, it flies 300 km east. So it flies towards east. And then 350 km at 30-degree west from north. Okay, west from north. So it's located on the negative x-axis and then the angle 30 degree, okay, you start to rotate the vector from north. So this statement is quite similar to the one that we see yesterday. And then 150 km north, and to arrive finally at airbase B. So how far will the pilot travel in this direct flight? Okay, so you want to calculate the resultant vector. So how are you going to calculate the resultant vector? Okay, because it says how far. So you start from an xy plane. Okay, xy plane. So this is x, this is y. And then now you move this vector one by one into your xy plane. Okay, you transfer them from the diagram into xy plane. So S1 is going to the right hand side, means it's located on the x axis. So this is your S1. S2 is 30 degree from the y axis and is located in the x axis, okay, negative x. So this is your S2. So this is your S2. So which is a 30 degree from north, 30 degree from your y axis. And then we have S3, which is going upwards to the north. So this is your S3. So this is the diagram that we're going to use in the calculations, okay, in the calculations. Okay, so let's see how are we going to solve it. Now that you have this diagram, now what happens when you have a vector that is located on the x component, x axis, or the y axis? Let's see. Okay, now, okay, I give you 2 minutes to try this question first. Okay, see how are you going to answer this question? All right, at least you try it. Okay, you tried it. So at least complete the table. Okay, see whether you know how to do it or not. Right, so now let's see how are we going to solve this question. Questions 2, okay, step number 2 is very simple. If you look at the diagram, now my vector is located on the x-axis, right? So for S1, the x component is straight away equals to 300 km. You don't even have to resolve it. Why? Because now the vector is placed on the x component. Then how about y component? Definitely is equals to 0 because it doesn't move along the y component at all. It is unlike all the other vector where they are being placed in between x and y component. Now you have this one whole vector that is being placed on the x component, right? That is located along the x component. Now S2, okay, S2 we have 350 km. Okay, and then if you look at the diagram, now the angle is beside y component. Therefore, for the x component, we are going to use sine. So 350 sine 30 degree. Okay, we use sines for x because the angle is located beside y component. But if you look at the diagram again, now that I have I have a minor mistake in my table. Why? Because I forgot to put in a negative sign here. So negative 350 sine 30 degree. Okay, because it's a second quadrant. So second quadrant, we have negative x and positive y. So y component is straight away equals to 350 cos 30 degree. Okay, cos 30 degree. And then for S3, okay, S3 again, now this whole vector S3 is being placed on the y-axis. Therefore, for the x component, it is equals to 0. Okay, and then y component straight away equals to 150. You don't have to resolve it. Okay, because now one whole complete vector is being placed on the y component. So same rules, okay? Once you complete the table, you calculate the resultants on the x component and also the resultant vector along the y component. So now we have Sx equals to 125 km. Okay, 125 km. Whereas Sy is equals to 453.1 km. 453.1 km. So once you obtain a resultant Sx and a resultant Sy, the resultant along x component and the resultant along the vertical component, okay, you can then proceed to the next step. But now again, I have an xy plane as usual. Okay, this is the xy plane. And then my Sx is a positive value. Sy is also a positive value. And then when I join these two vectors together, when I combine them together, it will give me a resultant vector in the first quadrant. I'm going to call it S without subscript. Okay, S without subscript. And again, the angle is beside x component. So that is the diagram for your resultant vector. Okay, resultant S. So now is the time to answer questions A. Questions A asks you to calculate the total distance travel, okay, the resultant value. Okay, if you go back to the questions, okay, it says, how far will the pilot travel in this direct flight? So direct flight means that it's from A to B. Okay, this is your S, the resultant, the total. So you add them up, and that would be the answer for your questions A. So S equals to square root x component square plus y component square. Okay, which is equals to square root 125 km square plus 453.1 km square. So the final answer is 470 km. Okay, if you got a value with a decimal places, you leave it. Okay, this one is from the answer scheme, they round it up. So you can have up to 2 or 3 decimal places. Okay, and then the direction. Question is asking about it's asking for the directions of the flight. So direction in a vector, it always refers to angle. So theta equals to tangent -1 modulus sy over sx, which is equals to tangent -1 453.1 over 125. Then modulus, which is then equals to 74.6 degree. Okay, so 74.6 degree in the first quadrant. Okay, so first quadrant above positive x-axis. Okay, above positive x-axis. So that is how you solve the questions. All right, so they just changed the way they ask question. Okay, but the things that they are asking for is still the same, which is the magnitude and also the angle. Okay, mereka cuma tukar bentuk soalan saja, tapi apa yang ditanya sebenarnya juga sama. Okay, dia masih tanya pasal resultant vector, dia masih tanya pasal angle. Okay, so again, I give you 2 minutes to complete these questions. So if you are done, you may proceed to questions number 7. Okay, questions number 7 is very similar to this question. Okay, it's very similar to these questions. You got 2 vector. You just have to think, how are you going to place these 2 vector into the XY plane? Alright, so sama juga 2 minit bagi anda catat jawapan, and then yang sudah siap punya, anda cuba soalan ke-7. Okay, kalau anda dah faham, actually you can finish whole questions within 5 minutes. Right, so you try a next question. So questions number 7 is very, very similar to question 6. All right, so you tried it. Okay, so the key part is the change in velocity. So change in velocity, you are not going to calculate the class, the total of resultant. Okay, you try to find the change. So I think the table, they give you the hints as well. So you use V minus U. Okay, rather than V plus U, you use V minus U. So you tried it. So you complete the table, yeah? You complete the table first, and then I will show you how to do it. Okay, now let's see. So a gas molecule hits the wall of a container with a velocity of 200 meters per second at an angle of 60 degrees to the wall, and it is being reflected with the same speed in the direction as shown in the figure. So what is the magnitude of the change in resultant, okay, change in the velocity of the ball? So instead of the resultant value, it is asking for a change. Okay, instead of a resultant, they're asking for change. So when it comes to the works change, we don't class the vector together. We subtract them. Okay, we don't add them up, but rather we subtract them. So let us do a diagram first. Okay, the free body diagram. So we have an XY plane as usual. Now U, we have it going towards a southwest. So this is your U. Okay, and then the angle is a 30 degree beside X component. And then our V is in the fourth quadrant. So again, it's 30 degree beside X component. So we have a U and we have V. So this is our diagram. Okay, this is our diagram. So now that we have all this, we have this diagram, we can then complete the table. So how to complete the table? For U and V, vector U and vector V, the method is the same. You look at the diagram and then you determine whether it is positive or negative, and then you determine whether you want to add them up or you want to subtract them. Okay, and then you want to use cos or use sine. Everything is based on the Cartesian coordinate. So for U, X component, now 30 degree is located beside X component. Therefore, I have my U, what is the value? Is 200. So 200 cos 30 degree. Okay, but now since it is in the third quadrant, therefore it is a negative 200 cos 30 degree. Y component, now third quadrant, therefore again we are going to have a negative sign here. 200 sine 30 degree. Okay, for V, okay, V is a positive X component, fourth quadrant. So we have 200 cos 30 degree. Whereas for the Y component, because it's in the fourth quadrant, again, it is a negative Y component. So negative 200 sine 30 degree. All right, now how are we going to calculate the change then? Change means you're going to minus final minus initial. Okay, whenever you have the works change, then it means final minus initial. So final here that we have is a V. and then initial is u. So you use vector v minus, okay, subtract vector u. So if you subtract them, what are you going to get? So v will be 346.4 meter per second. Okay, because 200 cos 30 degree minus negative 200 cos 30 degree. So actually it becomes plus. Whereas for y component, negative 200 sine 30 degree minus negative. So it becomes plus 200 sine 30 degree. Therefore, it is equals to 0 meter per second. Okay, so this question is slightly different than the previous question. Previous question asks you to calculate resultant, okay, or it asks you to calculate total. Then you add them up, you plus them. When you have a questions that involve change, then you minus, you subtract. You use final minus initial. All right, so now that you have a Vx and also Vy, you can then proceed to draw the positions of resultant vector. So again, I have x component, I have y component. Based on the table, my x component is a positive value. Okay, this is my Vx. And y component is equals to 0. That is a nothing. Therefore, the resultant vector is straight away equals to my Vx. Okay, it's straight away equals to Vx. So I'm just going to write down as V. So this is a diagram for resultant vector. Okay, the diagram for resultant vector. So how are we going to do the calculations? Very simple. Okay, so again, our delta V is now equals to square root Vx squared plus Vy squared. Okay, so which is then equals to 346.4 meter per second, because Vy is equals to 0. So actually the delta V is straight away equals to your Vx. And then direction, now it's located on the x component. So it's to the right. Okay, to the right. So you don't even have to calculate the angle. Now, if you want to calculate the angles, is it okay? Of course you can. Okay, of course you may. So it will become theta. Okay, it becomes theta equals to negative, and not negative, so tangent -1 modulus 0 over 346.4. Then you're going to get a 0 degree, then you have to describe it as well to the right. Okay, to the right. Because it's not above or below negative x-axis, or it's not below or above x-axis, it's not on the negative side, it's a positive side. So positive along the x-axis. Therefore, we say it is to the right. Okay, it is to the right. So if you do the calculation, then that is okay. That is also correct. Don't worry about that. But just remember to mention it is to the right. Okay. So far, any questions? Sampai soalan ini, ada seberang pertanyaan tak? Atau persoalan yang nak tanya?
Madam,
Ya.
kalau X yang kosong,
Kalau X yang kosong, dan dia akan menjadi upwards lah. Ke atas kan? Tulis upwards sahaja. Upwards atau downwards.
Okay.
So ada apa-apa soalan lagi tak? So kalau tak ada, saya rasa itu saja untuk hari ini. Okay, I will let you guys go a bit earlier. I'm not going to discuss dimensions yet. So dimensions, I will discuss it in a lecture tomorrow. Okay, dimensions, I will discuss it and I will finish it in the lecture tomorrow. And then, okay, after I finish the lecture, then you guys may try the questions in your tutorial handout. Okay, your exercise 1. So exercise 1 actually is very easy. Okay, exercise 1 actually is very easy. And then we are done. Okay, we are done with chapter 1 this week. All right, so that's all for today. If no questions, then you may leave the class. So if you have time, you can try the questions in your Telegram already, okay? The Feeboard. Feeboard, you got a lot of extra questions. So you may try it now if you want. All right, so that's all for today. You may leave the class now.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.